Class, welcome everyone. Let's begin today's class. I think do all the students attend today's class? Okay, we have a roll call. If someone absent, I will cut his short. Now maybe you can tell your friend if he is in campus, please let him come to the class. Tell him. Okay? Yes. Just leave there. 升样 here. Oh, he has a thing. Oh, I understand. Okay. 陈大卫 yeah. And 甄家 yeah. 孙书江陈文琪罗文 not here, right? 罗文 okay. Okay, it's done, man. Just familiar with my students. 莫友唐静雅 okay. 乐怡 not here. Oh, he's Africa. Oh, okay. Oh, just yeah. Let's continue. What's wrong? 王子文 Oh, 王子文 okay. Oh, yeah.乐怡 is not here. 王子文 is not here. Yeah. Okay, let's continue on today. And Zhang Li, can you help me to close the door? Let's continue today's class. And first, let's review what we learned last class. Okay. Yeah. And the last class we learned what's a concrete. Okay, I asked this question. Who wants to answer? Yeah. Okay. What's a concrete?
Concrete is like
yeah,
stone.
Stone.
Yeah. Material obtained by mixing.
Yeah. Mixing. Yeah.
Cement.
Yeah.
Water.
And what else?
Sand.
Sand. Yes. Sand is a fine aggregate, right?
Yeah.
And also there's another.
Coarse.
Coarse aggregate. Yeah. Gravel. Right. Gravel. Okay. For integrate. That's constitute. Yeah. Constitute the concrete. Right.
Yes.
Yeah. And do you still remember? Yes. Still remember that we sometimes we will use some add mixture.
Yes.
Yeah, add mixture, right? Like water reducing, like S flash. Okay, let's look at PVT, right?
Yeah.
Yeah, it's a like stone, but the stone is man-made, right? Man-made. Okay. And this is the mixture like mineral, fly ash, and this industrial waste. This mineral add in concrete that can sieve the cement. That's the purpose why we add the mineral in the concrete. Maybe it can improve the character of the concrete. But for why the purpose is to save the cement. Okay. And for chemical like water reducing or early strength that because we know the concrete at first they are in fluid state. We add these things just like to accelerate hydration process, to quickly to get let the concrete have a strong strength that can work. That's the purpose of the chemical that we add in the concrete. Okay? And for concrete, we also learned test, right? Test. We remember which the test? Slam test. To measure the workability. Workability of the concrete, right? Here's last class. I just roughly to introduce this slam test, but some students may be curious about that's why we not have the practical course like that you to do this real things. Because I have to see because it needs some special tools and some experienced teacher to carry. But for me, maybe it's I just know this test, but if for me to do this, I may not do it well. So So I should be honest, right? So so I found some video that you to real to see these things. And we use 4 minutes, okay? 4 minutes. For to see and that you to apply and how to carry this slam.
The ease with which one can work with concrete is called workability. This can be measured using a simple test called the slump test. Let me show you the procedure. Slump cone test is a simple and popular test extensively used at sites to assess the workability of the concrete mix. The test should be conducted at the commencement of the concreting operations or whenever the workability of the concrete changes. The apparatus for conducting the slump test essentially consists of a metallic mold in the form of a frustum of a cone with a base plate. A steel.
Look at here. If we begin the slam test, you should know the mold is a standard. The size should always be like 20 centimeters. Okay, this the bottom diameters. Okay, and the top diameter is 10 centimeters. We should use this standard mold. Then everywhere can accept this slam test. If sometimes we use a bigger, right? Bigger, the slam will be changed. But here's we should have this standard mode to carry this this test. Okay, so that's why if we do this experiment, we need some special tools. Okay, and okay.
A steel tamping rod of 16 mm diameter and 60 cm height is to be used for compacting. The internal surface of the mold should be thoroughly cleaned of moisture and any hardened concrete before commencing the test. The mold is placed on a smooth, horizontal, rigid and non-absorbent surface. It is then filled in 4 layers with the thickness of each layer being approximately 1/4 of the height of.
Okay, care about this value. We add the concrete always 25% each time to add in this cone, this slam cone, and add the concrete and use the rod to strike it, right? Strike it.
The mold. Each layer should be tamped 25 times evenly using the rounded end of the tamping rod such that strokes are uniformly distributed over the cross section. After the top layer is tamped, The concrete is leveled with a trowel so that the mold is filled exactly to the top. The mold is then removed by raising it gradually. The concrete will subside. This subsidence is known as slump. This operation shall be carried out without any jerks or vibrations and within a period of 2 minutes after completion of final tamping. The difference in level between the height of the mold and that of the highest point of the subsided concrete is measured. The subsidence measured is the slump of the concrete. The slump may either be a true slump, a shear slump, or a collapsible slump. The true slump
Here are the three failure modes. Yeah, okay, three failure modes.
is the desired form of slump that we require. In harsh mixes, the concrete slides down in an inclined plane. This is known as shear slump. In collapse slump, the concrete collapses as soon as the cone is removed. It usually occurs in very wet mixes. The concrete demonstrating a shear or collapse slump is considered unsatisfactory. In case of slump results beyond the specified limits, the mix proportion needs to be adjusted, especially the water content. The slump can also be varied by changing the proportion, size and combination of the various sizes of the aggregates. It is advisable to assess the workability of concrete mix using a slump cone. Ensure that the cone is filled in a proper manner as indicated. Notice the type of slump. Shear and collapse slump are undesirable. Adjust the slump to the desired value by changing the proportion.
Yes. And we measure the values, and sometimes it's not satisfied. So how to adjust, or we can adjust the proportion, the correct proportion. And these videos do not have the suggestion. This is the thing that come to here.
Value and it.
Well, this is a 3.
The slump value and it's acceptable. The slump value and it's acceptable.
This is a 3 failure mode. I hope everyone can remember or write down. Choose them, choose and then collapse. And then also here, for these tables, it had suggest some range values that for us to use in different types of structure. That's why if it's the slump value is too high or too low, may not good. It's the medium. Yeah, this is the things that we some from the last. Yeah, and another concept we mentioned that what's a reinforced concrete? What's the difference? Can some students tell me? Yeah.
Reinforced concrete has steel bars in it.
Steel bars? Yes. Okay, thank you. Yes, steel bars that in the reinforced concrete. Like, but here is we can widely see that the steel bars, but also has some steel tube, some fiber also can used in concrete that we name that reinforced concrete. And we'll have here, this is bigger, and here some properties of the material, concrete and steel we mentioned. And for this one, concrete with a tensile strength is only 10%, 10% of the compression stress. This is the character of the concrete, and also an important character that I hope everyone can remember that. And here we use examples to see, and yeah, this is the reason. And what I said to here, I proposed. Yes, I thank you for Ziqiao that great role for this course. Yes, and I upload textbook, textbook in the group, and also today I upload the video that for some students abroad, right? Abroad, they can download the video to learn. And yeah, I ask the students that download the textbook in group and to read it. Yeah, okay. It's just that he has, and yeah, done that. I hope, yeah, for learning, yeah, it's a really hard process, but I hope that you should use this chance, right? Use this chance. And for this book, in the chapter 1, there's a mention of design process. Design process that divide three design stage, okay, basic stage. And why we mentioned the design process here? Because it will help you to build a whole concept for this design process. And because future you will be the civil engineer, right? And we know this whole trust knowledge. Then for you, that will easy to realize what we learn now at which stage. Okay. For we to design buildings, there's several stage. Yeah, I will ask Qiao. Yeah, you said you read, and can you tell me which three stage design process? Do you remember?
One completion.
Calculation. Yeah, calculation is belong to the preliminary design stage. And the first is the concept design stage. Okay, I will tell you. This is the first is a concept design preliminary design stage. Third is the detail. This is three stage. Basic stage. Okay, and in different stage, we have different things to do. And in concept design, because in this there's no reality things for us. Here's in this stage, we only listen the client, the requirement of some because for we may like government, may like some boss, right? Boss, because he wants to build a factory, he will tell the civil engineer he wants to build a factory. For you as a civil engineer, you need to think, and the factory will at which place, and the function, and maybe the government will ask civil engineer to design a school, right, or hospital, or some different function buildings, right? This all things will happen in the concept design. Yes? Can you get what I mean?
Yes. Okay.
Yeah, in this concept design, we just collect information, right? Do not do the real thing because I mentioned in there it's a really big, right? We just talk things really roughly and really big, and here is a small, right? Small. And in here, yeah, yeah, it's okay if you have any questions or if you want to ask something, just ask. It doesn't matter if you're not familiar about what I said, because you know the Chinese person, right, use the English to speak. They sometimes will not get the point, and if you not understand, you can tell me. Doesn't matter. Okay. Yeah. Yeah. So that's the concept design. We make sure the function of the building and collect information, the building site and the usage, and may have because in different countries, right? In China, we use the Chinese code, and in Europe or in another country, in different countries, they will have his own code. This code will guide you to design structure. So at this concept design, we just collect the information for us. Yeah, just like the reinforced concrete, they will have different grade, and the type of steel bar is different, right? So in here, we just to collect, and then come to the preliminary design stage. At this stage, because we now know the type of the building, the function of the building, we can do some calculation. That's which type of calculation? Like we learned in structural mechanism, we can simplify the buildings, right? Because before, we know in reality, the beam look like this. But for calculation, right? For calculation, we will simplify this and for the boundary, we will use some hinge or roller hinge. And if there's a load, because in here, like the slab, right? The beam is also the beam. There is a slab on the beam. This is a slab, right? Because in reality, there will put some furniture, and people will live there. There's a desk, there's a table or something. But in the preliminary design stage, we will use some assumption. We will use some simplified method, yeah, to transfer this structural members at idea or theoretical models for us to do the calculation, right? Like the beam, we will simplify. Like furniture, we will like this uniform load or concentrate load, or maybe, right? And then we calculate it, get the internal force that's in the structure, right? Like there's a two important, the moment and also the shear force, right? And also we need to care about the load, the force on the boundary, right? And for we, and here, the preliminary design stage, we get these things, yeah, and then we use this load force to do the structure design and anything else. These things happen in preliminaries, but sometimes we will find what we simplify the method may be not correct. We need to revise it So it's the whole thing is not linear. It should iteration. I mean that you sometimes come to here and then to carry a scheme, but the scheme not satisfied, not good. So we throw this scheme in the bin, right? Bin, and to repeat, like do several iteration, and then we can propose accepted scheme, and then come to the third stage. Third stage is talk about the detailed design stage. That means sometimes we need the buildings can vary this, and also we need to know the steel bars, right? They will be rust. We need to put something protect it. Yeah, and these things we talk about in the detailed design stage. Yeah, and this is the whole, roughly, we divide this three stage to learn the concrete structure. And now we realize this three basic stage, and then we will know in which what we learn is belong to which stage, and then help you if you graduate from here, yeah, and in which stage you can do something and tell other persons. Yeah, and okay. Yeah, and for here's also, yeah, one important thing, a balance. There's a balance. That's some things we need to consider. This is a balance, okay? This during the maybe is on the second stage, okay? Here's what we need to know is because on the second stage they mentioned iteration, that because we need to satisfy the requirement on the concept design, but also as an engineer, we should know some details because for easy to construct. So here, one is the fitness on purpose. One is for economic, right? Because we build structure, it will cost time, cost resources, human resources, and cost time, cost money, yeah, to do. And fitness means that if we design a building, we construct a building, we hope it can work very long, yeah, work very long. That means the maintenance. Maintenance. So this just a balance that that's the meaning of the civil engineer. What ours work during this process. So that's the hours work. Yeah, and later I will also explain that detail. And here I also should mention that two things. For one thing is happened in the preliminary design stage, that is a hand calculation and also a computer calculation. Because now you know the buildings is a really complicated. What we learn now is just very fundamental. Fundamental is just a basic thing. Basic thing. And for the computer's calculation, you will learn in the next year. And the teacher's style will carry, will open these lessons for you. And but we need to know, as a person, we also should care about hand calculation. Do the hand calculations that can help you to track the result and calculate from the computer. Right? Because computer, I'm not sure that you may see some videos or not. Like computer calculation, that you just input some parameters in the computer system, and then the computer will calculate and will give you the result. But an engineer, that you should judge, right? You should judge and to track the result. Sometimes the computer's work is not correct. So that's for you, as you know you are the engineer, civil engineers. You can judge and can do some very key point and key calculation that you can calculate by your hand. That's the value. That's the worth of the civil engineer. That's the true thing between. So for hand calculation, also important. Also important in now, in these days. And here I clarified the 3 stage, and I also mentioned balance, that for the civil engineer, the work and the relation between the hand calculation and the computer's role. So maybe there's no pictures, no videos may feel tired. Here is just because in this chapter 1 is an introduction and help you to realize the basic things and to know some relationship between here. So sometimes you feel that it's okay. It's okay. And come to back. Let's talk about the reinforced concrete. Right? Reinforced concrete. That's here. Someone will ask why here we use the reinforcement concrete. Steel bars in the reinforcement concrete. There had 3 reasons. One is the bond. Bond means that the load applied on the concrete, that concrete can transfer the load to the steel bar, to steel bar. Then that means the steel bar and the concrete can work together. The bond is good, because sometimes some students will ask why we not use like plastic in the concrete. Because plastic do not have the good character like the steel bars. Because before, so other scientists, they do the test. They carry a lot of tests. They use different things to use in the concrete to test can it has a good count or not. Yeah, they compare. They find the steel, yeah, has a good. And in our life, some students may see, right? May see. For steel bar, they also have a different type, right? This is a steel bar. Some steel bars, the surface is really smooth, but some steel bar, they had the reverted, right? Reverted. Yeah, use the reverted, it's also true. Because here, you can imagine, right? For the concrete, use the reverted means it increased the surface, the touch surface with the concrete, right? But smooth is also okay, but sometimes people just want the high bond. High bond here, they will change the surface of the steel bars here. Will revert it. Yeah, that's the things. Here's the bond. Okay, the bond. And another is a similar coefficient of expansion. For this one, I explain here. The material, right? Material. When material put in the cold environment and in hot environment, do you know the behavior will be different, right? The cold, they have small volume. For the in hot environment, yeah, bigger, right? Bigger. So these things, people propose index that's named the coefficient of expansion. And for concrete and the steel bar, this index, these parameters, are really close. So that we can see in our surrounding the buildings that in summer, right? In summer and in winter, the steel bars, yeah, may you see some cracks happening, but we can accept, right? For the they will not like okay, how to see for in winter, right? Sometimes this is a reinforced concrete steel bars. In summer, they have a bigger value, means comes here, the steel bars also comes here. If they have a different coefficient of expansion, the summer, the concrete comes here, for steel bars only comes to here. So theirs will be empty, right? Empty. And there will have the high stress. That things will not good for the structure. Yeah, not for good for the member, structure member. Yeah, and another reason, okay, is a mutual benefit and a reciprocity. For these things I mentioned before, for steel bars, they had a good behavior in tension and a good in compression resist, but it's expensive, right? And yeah, and for concrete, they're good at compression, but it's cheap. Yeah, cheap. So they are mutual benefit because for steel bars can resist the tension, and for concrete they can resist compression. So these two materials used, yeah, mutual benefit. Yeah. And this is the three reasons to explain here. Yeah, the reinforcement and concrete work together and has a good behavior, and people like to use these two materials together. Yes, and here's yeah, take a rest. Take a rest.
Yes, doctor.